So good evening, everybody. We are going to do a short video tonight on really review of terminology that you've had before. And it's to begin our unit on congruent triangles. Very important unit, very important to all of our proofs that we do in geometry. A lot of times hinge on congruent triangles. So this is a pretty heavy proof unit, although we'll be doing some other things too. So to start the vocabulary, we'll go through some of the basics here. And if you'd like to take notes on this, you may. I have notes for you, so you don't really need to do that. And the worksheet that you have to do will probably reinforce most of what you need to know from this. And you can always go back to the video and look at the section that you need if you have forgotten. How do we name triangles? We use the vertices, each vertex. And so it's going to be named by 3 letters, and they can be in any order because it's obviously going to be consecutive no matter which way you do it. So there are several different ways to name this same triangle, and they are listed. We can classify triangles by sides or by angles. By sides, we have a scalene triangle, which is a triangle where all 3 sides are different lengths. I don't know why that triangle went up there. We have an isosceles triangle. Those triangles are ending up upstairs up here. You can't really see them. But anyway, we'll just go through the definitions. At least 2 sides are equal. So that's a very important definition because an isosceles triangle could also be equilateral. An equilateral triangle is a triangle in which all 3 sides are equal. So an equilateral triangle then by definition is isosceles. Whereas an isosceles could be but might not be equilateral. Sorry about that last slide. I don't know what happened. Okay, we can also classify a triangle by its angles. We can have an acute triangle. If that is the case, all 3 angles must be less than 90. We can have an obtuse triangle, and one and only one angle is greater than 90 and less than 180, or we have one obtuse angle. We could have a right triangle. We have one and only one 90-degree angle, and we can have an equiangular, and all 3 angles are the same measure, therefore they must be 60. Okay, these are maybe somewhat new. I think you've seen these words before, but just to reinforce them, they're probably not as familiar as the previous vocabulary. A median, the definition, is a segment from the vertex of the triangle to the midpoint of the opposite side. That is the definition of median. So what does it look like? It goes from a vertex to the midpoint of the opposite side. Since there are 3 vertices, there would be 3 medians. C, E, and F we've defined as the midpoints. So CD would be a median of the triangle. B, AF, and BE would also be medians of the triangle. An altitude is a special segment. It is the perpendicular segment from a vertex of the triangle to the segment that contains the opposite side. Notice this, the segment that contains the opposite side. So as you can see here, these are perpendicular, but in the case of, well, they're going to do a right triangle first. 2 of the altitudes are also legs, all right? This segment is perpendicular to this segment, and that goes from the vertex to the opposite side. In an obtuse triangle, however, 2 of the altitudes will fall outside of your triangle. So there's no way to go from B to side AD without, and be perpendicular without falling outside of the triangle. We do a lot with these segments in the next chapter. Nice, those are what those altitudes are going to look like. The perpendicular bisector is the line, right, or segment that is perpendicular to a segment at its midpoint. So it does not need to start from a vertex. That's a really important point about the perpendicular bisector. So this goes to the midpoint and it's perpendicular, but there's no way to do that from vertex E. So that is a perpendicular bisector. It has nothing to do with the vertex. In a right triangle, it just so happens that the perpendicular, well, it has other features, but we're not going to go into that. I'll leave that for later. In right triangle, MLN, AB is the perpendicular bisector. And in an isosceles triangle, the perpendicular bisector will in fact come from a vertex, as it would with an equiangular or equilateral. Opposite sides and angles, we've done this in the past when we did trig. So that's just being able to identify angles that are opposite sides and sides that are opposite given angles. And I think that's pretty second nature. Interior and exterior angles. Interior angles are the original angles that were shown inside your triangle. Exterior angles are angles formed by extending a side of the triangle. So for instance, if I extend this side here out, I get another angle 1 that is an exterior angle to that triangle. Parts. So we're doing anatomy of an isosceles triangle. An isosceles triangle is defined as a triangle with two congruent sides. The congruent sides are called legs, and the third side is called the base. So in this triangle, the legs are between angle 1 and angle 3, and angle 2 and angle 3, and my base is between angle 1 and angle 2. These are called the base angles, and 3 is called the vertex angle. And that is it. So you have that sheet to work on for homework, and we will continue with our discussion of congruency tomorrow. Have a wonderful evening.